I have some screenshots of a Wireshark packet capture that shows the process of a TCP three-way handshake and the termination of a TCP conversation. Let's analyze these screenshots to get an idea of how it's working. TCP is a connection-oriented protocol, meaning an end-to-end connection needs to be established first before data can be sent or received. The TCP three-way handshake initiates that connection. When the connection finally needs to be terminated, for instance, let's say it's a connection to a web server and you close the web browser, the connection is terminated with two-way handshakes. A TCP three-way handshake involves three steps: a SYN and an ACK, and an ACK. SYN stands for synchronization, and ACK stands for acknowledgement. First, the initiating host sends a synchronization segment. The responding host sends an acknowledgement and its own synchronization segment, and then the initial host sends an acknowledgement segment. Hence the SYN and an ACK, and ACK. We can see that here at the top of this screenshot. If we look at the packet list window at packets 10, 11, and 12, we can see a SYN and an ACK, and an ACK. This is the three-way handshake. If we look at the initial packet in the three-way handshake, the SYN segment up here at the top, we can see that the sequence number is 0. The beginning of a three-way handshake is sequence number 0 because it's the first packet in the connection or conversation between two hosts, or in this case, a host and a server. The sequence number is actually a 32-bit random number called the ISN, or initial sequence number. This random number, or ISN, is chosen randomly at the beginning of each TCP conversation. This helps to protect against TCP connection hijacking attacks. Wireshark takes that 32-bit random number and converts it to 0. It then increments the sequence numbers and the acknowledgements from there. This makes it easier to read and follow the segments in order using the Wireshark program. Let's look at a few of the details for this initial SYN segment. We go down to the packet details window and we can see sequence number 0, that it's the relative sequence number. If we look at the flags, we see that the SYN bit has been set. You can see it here with a 1. In the next packet, packet number 11, the server responds to the initial synchronization segment. I'll go to the next screenshot, and now packet 11 is highlighted. The server responds with an acknowledgement acknowledging sequence number 0 and sending acknowledgement 1. So the initial sequence number with relative sequence number 0 has been incremented and acknowledgement 1 has been sent. We can see in the protocol details window acknowledgement number 1 and that it's the relative ACK number. The server has also sent its own synchronization segment, and that number is 0 since it's the initial conversation going the other way. If we look in the details window, we can see that the sequence number is 0, and that's a relative sequence number from the server to the host. If we look here at the flags, both the SYN bit and the ACK bit have both been set. If we go to the next screenshot, in packet 12, which is step 3 in the three-way handshake, host 10.1.1.1 responds with an acknowledgement, or ACK, and if we look in the protocol details window, we see the acknowledgement number is 1, incrementing the server's synchronization segment by 1. You can see here that the acknowledgement bit has been set, but notice that the SYN bit has not been set. This is the final phase in the three-way handshake. Let's take a look at how the TCP connection terminates. I'll go to the next screenshot, and you can see in packet 16, the server is communicating to the host at 10.1.1.1 and has sent a segment with a finish or fin and an acknowledgement or ACK. In this segment we have a fin and an ACK. The fin ends the conversation. The acknowledgement flag has been set since the three-way handshake was first established, and in every segment sent thereafter, the acknowledgement flag is set. You can see that in the next packet, packet number 17, the host has replied to the server with an acknowledgement acknowledging that the conversation has ended. This is a two-way handshake, a fin and an ACK and an ACK. If we look ahead in the packet list window to packet 18, you can see that host 10.1.1.1 then sends the server its own fin and acknowledgement, and then the server replies with its own ACK. So you have two-way handshakes to terminate the connection. If I go back to the previous screenshot and take a look at the protocol details or the packet details, we can see here in the TCP segment the flags. Notice the 1 for the acknowledgement and then the 1 for the finish or fin flag here that's been set. Notice that the acknowledgements went as high as number 374, indicating that these screenshots were probably generated from two separate packet captures in Wireshark. You can see in these last two screenshots how the conversation ends with two-way handshakes, a fin and an ACK, and then another one going the other way.